The nucleotide is the building block or monomer structure of the nucleic acid polymers DNA and RNA, essential biomolecules for all life force on Earth. It is made up of a phosphate group, a 5-sided pentose sugar which is either ribose or deoxyribose and therefore differentiates DNA from RNA, and a nitrogenous base. The sugar in ribonucleic acid is ribose, and the sugar in deoxyribonucleic acid is deoxyribose, which has one less oxygen atom than ribose. In ribonucleotides, carbon 2 and carbon 3 have an OH group attached, whereas in deoxyribonucleotides, carbon 2 has a hydrogen atom attached and carbon 3 has an OH group attached. The 4 bases that could be in a DNA nucleotide are adenine, thymine, guanine, and cytosine, and the 4 bases that could be in an RNA nucleotide are adenine, uracil, guanine, and cytosine. Therefore, the only bases that differ between these two biomolecules are thymine and uracil. Each nucleotide is named after the base it contains.
There are 4 general functions of the nucleotide. It is the building blocks of nucleic acids, it forms coenzymes, it contains metabolic regulators, and it synthesizes polysaccharides.
Nucleotides and DNA join together to form the DNA double helix structure that Crick and Watson first discovered in 1953. This consists of a sugar and phosphate backbone and bases located in the middle. The backbone is joined together by a phosphodiester bond, and the bases are joined together by hydrogen bonds, keeping the double helix structure intact. In DNA, adenine only bonds to thymine and cytosine only bonds to guanine. This is because of the structural nature of these amino acids, with one of each pair being a purine base of the double ring structure, adenine and guanine, and the other being a pyrimidine base of the single ring structure, cytosine and thymine. This is known as complementary base pairing. The phosphodiester bond that forms the backbone of the DNA structure is between the OH group at the third carbon of one nucleotide and the phosphate group at the fifth carbon on the other nucleotide. This results in a slightly skewed structure of DNA and RNA.
RNA is composed of a single-stranded helix. Like DNA, it contains purines and pyrimidines. However, uracil replaces thymine in RNA. It is formed from DNA by the process of transcription. Its main function is that it provides a nucleus with codes to make protein.
DNA mutations are caused by a change in the nucleotide sequence of the double helix structure. Mutations can be so small that the change could be in a single base pair of a nucleotide, known as a point mutation, as seen in cystic fibrosis.
RNA mutations usually occur with viruses. The influenza virus and HIV virus are the 2 most well-known examples. RNA genomes have much higher mutation rates. This is so that viruses can evolve. They are less likely to be noticed than DNA mutations. This is due to the base uracil, which does not occur in DNA.
Created using Powtoon.